Here we have waves, electromagnetic waves with their frequencies and corresponding energies. 8.1 says describe how an electromagnetic wave propagates. So here we have we say that accelerating electric charges, produce perpendicular electric fields. Which produce perpendicular electric fields produce perpendicular magnetic fields there, which produce perpendicular electric fields, which produce perpendicular magnetic fields, continuous like that. So accelerating electric charges produce perpendicular electric fields, which produce perpendicular magnetic fields, which produce perpendicular electric fields, which produce perpendicular magnetic fields. And an electromagnetic wave, a wave of changing electric and magnetic fields that are producing each other, propagates in that way. 8.2 says, what is the relationship between frequency and energy of an electromagnetic wave? And from this equation, energy is equal to Planck's constant multiplied by frequency. We can see that frequency and energy are directly proportional. And if they're directly proportional, the higher the frequency, the higher the energy. So we can simply just say that the higher the frequency, the higher the frequency of a wave, the higher the frequency, the higher the energy of an electromagnetic wave there. To here as well. Okay. All right. So 8.3.1 says that calculate the frequency of wave E. So wave E, we have energy. So we're supposed to calculate frequency from energy. Now, how do we do? Let's get this right over here. All right. Okay. Now, how do we get frequency from energy? So the energy and frequency formula is energy is equal to Planck's constant multiplied by frequency. The energy for E there is 4,97 multiplied by 10 to the power of negative 14 right over there. Is equal to Planck's constant is 6,63 multiplied by 10 to the power of negative 34. It's a constant. And then the frequency is what we are trying to calculate here. And then to solve for frequency, we are going to be dividing here by Planck's constant, 6,63 multiplied by 10 to the power of negative 34. There, we are left with frequency. Do that also on the left-hand side. Divide by 6,63 times 10 to the power of negative 34 there. And the frequency will be equal to, when we put this in our calculator, we have 4,97 multiplied by 10 to the power of negative 14. Divide by 6,63 multiplied by 10 to the power of negative 34, giving us 7,5. There 7,5 multiplied by 10 to the power of 19 units for frequency is hertz there. Okay. And then says then 8.3.2. Okay, 1, 2, 3. 8.3.2. Wavelength of wave D over there, we have energy and frequency. We have both energy and frequency, so you can calculate from both, but it's easier to calculate from frequency because the formula then is the speed of light in a vacuum is equal to frequency multiplied by wavelength. The speed of light in a vacuum is a constant, is 3 multiplied by 10 to the power of 8 is equal to the frequency for D over there is 1,8 multiplied by 10 to the power of 18. we want to calculate the wavelength, so we are going to be dividing here by 1,8 times 10 to the power of 18, so that we are left with wavelength. Do so on the right hand side. We must also do that on the left hand side. Multiply by 10 to the power of 18, divide by that, and then the wavelength will be equal to, on our calculator we have 3 times 10 to the power of 8 divided by 1,8 times 10 to the power of 18. They're giving us a 1,67. We have 1,67 multiplied by 10 to the power of -10 there, meters there. And then it will be 1, 2, 3 there. 8.4 says there, 8.4 says, which wave A or B has the higher penetrating ability? Penetrating ability goes with energy. So the answer A or B, B is the one with the higher penetrating ability because it has the higher energy there. I don't have space for that, but let me just say there, 8.4 over here, B, because of a higher energy, it has the higher energy there. That's why it has the higher penetrating ability. Electromagnetic waves have higher penetrating ability if they have a higher energy. So the higher the energy, the higher the penetrating ability. You can say gamma rays have the highest penetrating ability compared to ultraviolet rays, for example. That's because gamma rays have the highest energy. Now, sometimes it can be confusing when you look at the numbers in scientific notation for energy. One might think that just because this is to the power of 21, this is to the power of 24, that means that one is higher. But the sign, the sign there of that exponent there. So a negative 21 is bigger than a negative 24 there. So the exponent there for the energy there might maybe confuse one a little bit, but negative 21 to the power negative 21 compared to the power of negative 24, negative 21 is bigger than negative 24. So if they were positive, the exponents, then we'd say the 24 is bigger. But then because the exponents are negative, the higher energy is B with the negative 21 compared to the negative 24 there. Okay. Okay, that will be 2 for that. And this is a 10. This is out of 10. And how did you do out of 10? It's 12 actually. This is 12. How did you do out of 12? Okay.